All right, this video is on 6.2D, adding and subtracting rational expressions. So first, let's go back to just the basics. When you add and subtract with like denominators, so when the denominators are the same thing, you add the numerators and the denominator stays the same. So like 2ace plus 5ace would be 2 plus 5 is 7 ace. So they're the same things. So you can add them together. It works the same way with rational fractions. So as long as you have a common denominator, which means that the bottoms are the same, then you can just add or subtract the numerators. So like 3 minus 7 or 3 plus negative 7 be negative 4 over 2x. Then this does simplify more, since negative 4 could be negative 2 times 2. You can take out the 2's. So this would be negative 2 over x would be the final answer there. Okay, these ones have like denominators, so you can add the numerators, but this time the numerators are not like terms. And so to add them, it just looks like this. It's just 3x plus 6. I can't combine them and say 9x because the 6 is not a like term. All over x minus 4. Now, I don't think you can simplify this anymore, but you could take a 3 out of the top and get x plus 2 over x minus 4. And so it doesn't simplify further, so either answer would be fine, this one or this one. If you don't have common denominators, you need to find the least common denominator. So when adding, if I have like just in general a over c plus b over d, I need a c and a d. So I can multiply this fraction by d on both the top and bottom, because that's essentially I'm multiplying that fraction by 1, so I'm not changing it. And then I'm multiplying this fraction by c over c, again multiplying by 1. So then I'll get AD over DC plus BC over DC. Now they have common denominators. So then it's AD plus BC over DC. Might make more sense when we have actual numbers. So 3 and 7. Now, you can find the lowest common denominator by listing factors of 3 and factors of 7 and find what they have in common. So I will start with the bigger numbers, so like 7, 14, can't divide either one of those by 3. 21, I can divide 21 by 3. So 21 is my lowest common denominator. And it, in fact, 7 times 3 is 21. So I can multiply the first fraction by 7 over 7. So multiplying it by 1. So I'm just manipulating it so it has a bigger denominator, but it's staying the same value. And then I'll multiply the second one by 3 over 3. So I'm going to get 7 over 21 plus 6 over 21. And now I have a common denominator. The denominator stays 21. And 7 plus 6 is 13. Okay, so it'd be the same idea with the subtracting. You would have that AD minus the BC over DC. You would need the DC. The first one would need a D and the second one would need a C. So when you look at this one, 5, you need a 5 and you need an x. So 5x is going to be your lowest common denominator. So I'm going to multiply the first fraction by x over x. Essentially that's 1, because x divided by x is 1. And I'm going to multiply the second fraction by 5 over 5. So that's going to give me 3x over 5x, which you can see would reduce back down to just 3/5. And then minus 10 over 5x, which again would reduce to 2 over x. But now they have common denominators, so I can subtract. So it's going to be 3x minus 10 all over 5x. So I can't combine the 3x and the 10 because they're not like terms. And I can't simplify because I can't take anything out of the top. And so that is your final answer for that one. Okay, so you just need to have the same denominators. So I can make this 2 a 4 by multiplying it by 2, and I can make this 4x and x cubed by multiplying it by x squared. So then your lowest common denominator is going to be 4x cubed. So whatever I did to the bottom to make them the same, you do it to the top. So I need to multiply this one by 2 over 2. So I get 14 over 4x cubed, and then plus 5x squared over 4x cubed. Then I'm going to add these together, and I'm going to put it in standard form. So I'm actually going to add 5x squared plus 14 all over 4x cubed. So not like terms, so I can't add them together on the top. And I can't take anything out of the top either, so I can't simplify anymore. Remember that this x squared on top is connected to the 14 with the addition, so you can't simplify the x squared and the x cubed. In order to see what the next example has for like terms, you do need to factor the first one. So factors multiplies to -6, adds up to -1, -3, and 2. It is just x squared, so that'll be x minus 3 and x plus 2. So my second fraction has an x minus 3, but it needs an x plus 2. So x minus 3 and x plus 2 is going to be my lowest common denominator. Or essentially, x squared minus x minus 6 is your lowest common denominator. This trinomial right here. So if I multiply the second fraction by an x plus 2 on the bottom, I also have to multiply by an x plus 2 on the top. The first fraction doesn't need anything, so I don't need to multiply by anything there. I'm going to take this, it's positive 5, so I'm going to distribute the positive 5 into here. I'm going to get 4 plus 5x plus 10 all over x minus 3 and x plus 2. So then you can combine the 4 and the 10 on top, so it'll be 5x plus 14 over x minus 3 and x plus 2. And I'll accept this answer, or I'll accept the 5x plus 14 all over, and you can put it back in standard form like that, if you know it doesn't simplify. I tend to leave it in simplest form just so I know if it doesn't simplify any further. Okay, this one, first factor the bottom of the first one, so multiplies to 12, adds up to 7 is 3 times 4. So it'll be x plus 3 and x plus 4, which means my second fraction also needs an x plus 4 on both the top and bottom because it already has an x plus 3. So your lowest common denominator will be x plus 3 and x plus 4. Now this time you need to distribute a -5. So it's going to be 4 minus 5x, and then -5 times 4 is -20. So since it's subtraction, you have to distribute a -5 instead of a +5. And then it's similar, combine your like terms. So it'll be -5x and then -16 all over x plus 3 times x plus 4. Or -5x minus 16 over x squared plus 7x plus 12. Either one. Okay, you're probably catching on. I think I'm going to do maybe one more example, but if you've got it by now, you could stop. This one does have 3 factors in the denominator, so you want to see what that might look like. It is a little bit more complicated example. So to factor the first denominator, I get 9 that adds up to 6 is 3 and 3. So it'll be x plus 3 times x plus 3. Then the second denominator is difference of perfect squares. So it's x plus 3 times x minus 3. So to make a common denominator, since my first one has 2x plus 3's, my second one needs 2x plus 3's. So 1, 2. And I also need an x minus 3. So this one will need an x minus 3, which means I need to take this times x plus 3 up here and this times x minus 3 up here. So I'm going to multiply this out. Since it's two factors multiplied together, you have to FOIL this or use your box. So if I FOIL that, I'm going to get x squared plus x minus 3x minus 3. And then it's going to be minus, you have to distribute the negative 1. It'll be minus 1x and then minus 3 on the top. All over, and I would probably just keep this in factored form. X minus 3, and then it's x plus 3 squared. You have 2x plus 3's. Okay, combining my like terms on the top, I just have 1x squared term, and then I have an x, a 3x, a negative 1x. So adding from left to right, make sure you follow the order of operations. So from left to right, x minus 3x is negative 2x, and then negative 2x minus 1 is negative 3x. And then negative 3 and negative 3 is negative 6. All over x minus 3 and x plus 3 squared. So I'm just going to double check and see if that factors more on the top. So anything that multiplies to negative 6 but adds up to negative 3. 1 and 6, 2 and 3. No. So it doesn't factor anymore on top. So we would be done. If it did factor more, you'd want to factor it just in case you could simplify or cancel anything on the bottom. Okay.